This is a review for arithmetic and geometric sequences, and so we're having a test tomorrow. And so the first thing you need to do is go to Google Classroom, and in Google Classroom, so here's Google Classroom, go to class, whatever it is. Go to classwork, and the very top thing is Desmos. Click on Desmos and click on that. Or you can always just Google Desmos Texas and that'll pop up. You can get it on your phone, either Android or an Apple. And so we're going to use this today to go over the review. You should have gotten a paper copy in class. And so this first question is write an explicit formula for each graph. And so we're going to use the calculator to do that. But before we do that, we need to make a table. And so anytime we do our table, it's going to be the term number and then the term. And so these are disordered pairs. And so my first term is 3. My second term is 5. My third term is 7. And my fourth term is 9. And then I have this other one. Fifth term is 11. You should know, since this is linear, then that means that our sequence is going to be arithmetic. As I was writing these down, you could have found your common difference. What's your common difference between each one of these? It is add 2. So if the question asks for a recursive formula, it's a sub n equals a sub n minus 1 plus d. And so all you have to do for recursive is a sub n equals a sub n minus 1 plus 2, because every time we're just adding 2. That's the recursive. But the question is, what is the explicit? Well, if I want to do the explicit one, it's going to be a sub n equals the first term plus the difference times n minus 1. So you could do this by hand. A sub n equals, my first term is 3 plus my difference is 2 times n minus 1. This will work, but then we can also use our calculator to do this. And so, this way. And the first thing you're going to do is we're going to create a table. So over here, click the plus and table. You can use your keyboard. I'm going to use this. 1, 2, 3, 4, and 5. That one. And then I'm going to come over here and I'm going to put 3, 5, 7, 9, and 11. We can see right here that this is our, you can click on those too, those are our points. If you couldn't see them, you press that and it zooms in. But what we like right here is this magic button right there. There's that magic button we press. And when we press that magic button, the equation connects the dots. And if that equation connects the dots, then that is our explicit formula. So we get y equals 2x plus 1. If we had taken this 3 plus 2 times n minus 1 and done our distributive property, 2 times n is 2n, 2 times 1 is negative 2, and then I add 3 to that. Well, that's a sub n equals 2n plus 1. It's the same thing. If I wanted to create a table on this, I hit that thing right there. And then the gear, y'all say settings and table. And to check to make sure My first number is 1. My second number is 5. If I put a 3, you can just type over. There's 3, it was 7. And so that is my correct answer. So we're done with this. So 2 ways to get rid of all this stuff. You've got these X's you can do, or you can do gear and delete all to reset it. This is going to be in your test tomorrow and on the STAR test. So here, I need to make an XY table with my term number here and the term here. And so I have, that's going by 2, so it's going to be 1, 10, 2, 20, 3, 40, and 4, 80. Now, on a, this is not linear. It is, hopefully you know, this is exponential. Since it is exponential, that means it's going to be geometric. And so I have to find my common ratio. Well, my common ratio is, how do I get from here, 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 here? Well, hopefully you figured out it's multiplying times 2. So I could find a sub n equals a sub 1 times r. It's best if you always put that in parentheses, raised to the n minus 1 power. So we could do a sub n equals, my first term is 10 times, my r was 2 raised to the n minus 1. And I need to know what that looks like on my calculator. So I'm going to come back over here. I'm going to add a table. And I'm going to do 1, 2, 3, and 4. And I'm going to get 10, 20, 40, 80. We already said we can't see that, so we're going to do this magnifying glass right there. And so that makes my my exponential, and I can see it. And so I'm going to do this, whatever, this magic button below the plus sign right there. And I get a linear regression. Notice my points don't line up there. I need it to go through these points that are right there. So it's not linear, it is exponential. So you've got to remember to change it to exponential. Then here is my equation. Y equals 5 times 2 to the x power. If you want to see if what we got before is the same as that one, remember here you can do this and get in your table, you can do that. You can also say, okay, well, I have if it's a subscript, you just put it in parentheses, a sub n equals 10 times 2, you push this a, b, I'm raising it to the, you have to put it in parentheses, n minus 1. So here we go, n minus 1. And then automatically, right here, hopefully you saw, if I go undo, it's blue, but then whenever I put the 1 in, it graphs right on top of it, and those are the same equations. So my next one is create the first 5 terms of the sequence as a list, table, and a graph. And so I need to rewrite this to put it in my calculator. I'm going to say f of n equals f of n minus 1 plus 3. And I need to know that f of 1 is 2. So, my calculator, x, get all this gone, delete it all. I'm going to put f of n equals f n minus 1 close parentheses, plus 3. Then it says add base case. And so if it looks like this, I have to go here and say that f of 1 equals 2. When that happens, this magic table thing to the left in gray goes there, and I press it, and then magically it comes up. And so I want my first 5 terms, and so that would be, my first 5 terms are 2, oh, I can't see anymore, 2, 5, 8, 11, and 14. 2, 5, 8, 11, and 14. You could have figured that out yourself, because you could have said 2 plus 3 is 5, plus 3 is 8, plus 3 is 11, plus 3 is 14. You can do that also, but this gives you peace of mind that you can do that. Now, I need to make an XY table, so I'm going to make an XY table. So 1, 2, 3, 4, 5, and then I have 2, 5, 8, 11, 14, and I'm going to plot those points. So 1, 2, 2, 5, 3, 8, 4, 11, 5, 14. And that's what you do with that. Then the next problem is a sequence can be generated by using m of n. So we're going to rewrite it. M of n equals r times m n minus 1. And they told me that m of 1 is 5 and r is 4. So I've got to put this r as a 4. But it's important that I know that. So I've got my calculator, x, and I'm going to type in m of n equals r, but instead of r, I'm going to put a 4 times, it's always best if you just stick that second number in parentheses. Well, no, I'm not going to do that. Never mind. I lied. I'm going to put m. If it's an exponent, put a parentheses. And then we're going to put n minus 1. Oops. N minus 1. And so it's going to tell me to add a base case. So I've got to say m of, what they tell me, m of 1 equals 5. And I need to know, what's the question? What are the first 4? So the first 4, I'm going to make a table right there. 5, 20, 80, 320. 5, 20, 80, 320. Oh, that was only 4. Oops. Can't count. 1280. In the sequence of numbers, P of 3 is negative 48, P4 is this. This means that the third term is negative 48, fourth term is negative 96, and so on and so on. So if you needed to, you could make a table, 3, negative 48, 4, negative 96, 5, negative 92, 6, negative 3, and 4, and 7 is negative 7. So I'm going to take my answer choices that are over here. My calculator. And I'm going to go negative 48 times, I'm going to put this 2 in parentheses, and then I'm going to raise it to the n plus 1. N plus 1. And then Oh, I forgot to put the first part. I forgot to put the P of n equals. Oh, I goofed up too. You are going to have to watch it. I have to do raised to the open parentheses n plus 1. N plus 1. And so now I get a table, and look at that. I'm going to put 1, 2, 3, 4. Oh no, that's not what I should have put. 3, 4, 5, 6, and your favorite combo 7. So I looked at this table does not look like that table, so that means that this is a stupid answer. So I get my calculator back. Here's the best part about this. I can just click in there and I can delete that and put a minus sign. And then look, negative 192 is not negative 48. So that is not the right answer. So that's a stupid answer. So now I need to change this 48 to a 12 because the numbers, oh, bless, what happened? 12. And then this n is a, well, look, I didn't change it yet, but if you look, negative 48, negative 96, negative 192, my answer is D because it was an n minus 1. That's how you use the calculator to do that. Sequence can be generated by the following. I need to rewrite this so I can put it in my calculator. R open parentheses n equals 3 R open parentheses n minus 1. And then what's important is R of 1 is 1/2. So my calculator, here we go. I'm going to put R of n equals 3 open parentheses R open parentheses again, and I gotta put my n minus 1. And it asks me what R of 1 is, so I put my R of 1 equals 1/2. So 1 divided by 2. And then, see this fancy little thing to the left of my blue? That means I can turn it into fraction, but it's already a fraction. But the question is, what's the first 5 numbers in the term? And so I add my table, and I've got it right here. So I've got 0.5, like this. I have 0.5, 1.5, 4.5, 13.5, and 40.5. Those are the first terms. Now, sometimes stuff is going to ask you, well, I want that as fractions. So we come down here to 4. Let's say I want to turn 40.5 into a fraction. I just type 40.5 and then push that fraction, and it, does it not change? There it is, 81/2. That's all you have to do to change it into a fraction. All right, for the sequence, identify the recursive and simplified. So recursive, so first of all, we need to find the difference. Do we have a difference? Is it geometric or arithmetic? So this I have to subtract 4 from here to here. Oh, I subtract 4. I subtract 4 every time. So that means that my common difference is -4. So a recursive is all the time a sub n equals a sub n minus 1 plus the d. So here we have a sub n equals a sub n minus 1, and my d was -4. That's all you have to do for the recursive one. The explicit one, a sub n equals a sub 1 plus the d times n minus 1. So you can do this. A sub 1 is, my first one was 5.5. And then negative, oops, got my plus, nope, minus 4, and then n minus 1. So this is explicit, but it didn't simplify it for us, so we're going to let the calculator do that. So I've got this, and x, 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 x. I'm going to do a shortcut way. Well, no, we'll do it this way. Or add a table, and I've got 1, 1, 2, 3, 4, 5, and then I have 5.5, 1.5, negative 2.5, negative 6.5. Did I mess up? Oh no, I didn't. And then negative 10.5. So now I'm going to press this button right there. It's linear. I'm going to press that button. And oh, there it is right there. Y equals negative 4x plus 9.5. Y equals negative 4x plus 9.5. There's the explicit one. The next one, dear population, we did this one in class. So you have the easiest way by hand. 2015, I start with 75. I got a triple each here, so you take 70, this 2016, this times 3, and then you take this number, and it's going to be times 3, times 3, and you keep going until you get to 2020. Ask me about that one if you have questions. Determine the 67th term of the sequence a sub n equals a sub n minus 1 minus 2.2. You've got to know, you've got to rewrite this with, if it's an n, you have to put it in parentheses. And so I know that the 41st term is 21.3. I need to know the 67th term. So I'm here. A of n equals a of n minus 1 minus 2.2. And it's going to ask you for a case, so we're going to say a of, they gave me 41 equals 21.3. And so I can press that table, or here's something else I can do. I can say I want this, the 67. I could instead just say a of 67, and that number is negative 35.9. There you go. Same thing. I need to know what the sixth term is. So I need to know what g of 6 equals. When g of n equals g of n minus 1 times negative 3. And g of 4 equals 12. Coming over here, I'm going to be lazy. And it doesn't matter what your letters are. I'm just going to come over here and I'm going to change my business right here and say that this was times negative 3. And then I'm going to come right here and say that I know a of 4 is 12. And I want a of just a normal 6. My answer is 108. Tomorrow we have a test. I hope you study and watch this video. you have any questions, come in for tutorials or email me.